This is one of two videos which focus on recrystallization. We'll have an exam questions video and this video as well. And this will go over the basics of recrystallization, how you use recrystallization to create a pure solid. Really, it's important that you know it's a solid we're working with here with recrystallization. And we'll use 2,4-DMP as the example of where you can recrystallize, because this is one of your required practicals throughout the course. So let's go back to our map here through practical techniques. And first of all, do the synthesis. So the synthesis, as said in other videos, is two-stage. We've talked about that being reflux or potentially distillation when it comes to aldehydes, for example. Now, we also talked about purification. If you have an aqueous and an organic layer, you can separate those aqueous and organic layers and neutralize the acid within or base within the actual reaction mixture using a separating funnel. Now, if after you've done that, your solid crystallizes out and you get a nice solid, for example, like this, okay, that solid can be purified using recrystallization. So what you're doing is the crystals, you're turning them back into crystals. So we'll dissolve them and then turn them back into crystals. Hence, this is recrystallization. Now, the most common example of recrystallization to get a pure solid is identifying aldehydes and ketones with 2,4-DMP. So we're going to use that to go over recrystallization. So just a reminder of identifying aldehydes and ketones with 2,4-DMP. Both aldehydes and ketones have carbonyl groups. So you can see the carbonyl groups being highlighted on the right there for a ketone and an aldehyde. Okay, now 2,4-DMP, or you can call it 2,4-DMPH, reacts with the carbonyl group that's highlighted on my right. Now, this carbonyl group can react to form an orange or yellow precipitate. And you can see the orange or yellow precipitate here, but when we go actually into the lab, we can see this being made, and it's quite beautiful. And I do love it when you do recrystallization and you can see the solids just falling down in waves. Okay, but you'll see that and hopefully you'll enjoy it too. So this orange or yellow precipitate, which we can see over there, confirms the presence of that carbonyl group in an aldehyde or a ketone only. So only those two. Okay, so nothing else that contains a carbonyl, just the aldehyde or the ketone. Now the reaction is as follows. You don't need to know 2,4-DMP, but I do show it just to give them an idea of what happens. There's your ketone. And this carbon of the ketone will react with this nitrogen and turn it into a double bond. You can see this double bond. Okay, that means I get rid of this oxygen, I get rid of these two hydrogens, and essentially it's a condensation reaction. Now, what we're going to do is take you into the lab and we'll show you how to do this recrystallization, and then we'll come back to the studio and we'll go through the exam. In this video, we're going to talk through the reaction of a compound containing a carbonyl group with 2,4-DNPH. 2,4-DNPH also stands for 2,4-dinitrophenyl hydrazine. And do not worry, you do not need to remember that word or that name. You just need to remember 2,4-DNP or 2,4-DNPH. Now, 2,4-DNPH is in this boiling tube here. So you can see it's a very orange colour, unmistakable. Okay, and we're going to add it to a ketone. So when I say carbonyl, precisely, this is a test for a carbonyl that occurs in a ketone or an aldehyde. So we've chosen a ketone to put in this boiling tube, and that is butanone. And we've also put in the other two reagents, which is methanol and sulfuric acid. And together this is known as Brady's reagent. All you then do is take the two samples and then you add them together. You see straight away that the precipitate is produced, okay, and you have this orange kind of precipitate. Remember, it can also be yellow depending on what it is, and you have that precipitate produced, which proves you have a carbonyl inside your molecule. So what we can do now is we have to recrystallize this sample to turn it into a more purer sample. We're now going to do recrystallization. So you have to describe this in your exams, so it's really important you understand. So here we have our 2,4-DNPH derivative. This is the ketone or aldehyde that has reacted with your 2,4-DNPH. And we're going to take this precipitate and we are going to dissolve it in a minimum amount of hot solvent. So we have a recently boiled kettle right here, and we have our solvent in the boiling tube in here. You've got to make sure that it's very, very hot, so make sure that is a recently boiled kettle, okay, and make sure that you have enough solvent to do the recrystallization. Now normally you would add a minimum amount of hot solvent to make sure that your product crystallizes out at the end. So that minimum amount of hot solvent is really, really important. But for this video, we've measured out the exact amount of solvent that we need. So that's why we're just going to add all of this in here. So what we're going to do is take the hot solvent and then pour it into this derivative. So now we're going to put it into that freshly boiled hot water, and we're going to make sure we stir it. It's going to take a little bit just to warm up. And as we stir it, what should happen is the product will dissolve, and it will dissolve last because it doesn't dissolve very well in the solvent, but the impurities must dissolve really, really quickly and will dissolve really, really quickly. And now you can see that that's fully dissolved because of this hot solvent. All we have to do now is put it straight into the ice bath. This should happen almost straight away, and you put it straight into the ice bath, and that should mean that the product will recrystallize out and the impurities will stay in the solvent. And you can see that here, you can see it's falling, and you can see this solid material falling to the bottom of the boiling tube. So we have our recrystallized pure solid with our impurities in the liquid, and we're going to perform filtration. So filtration is done via a vacuum trap which is attached to a water tap. Okay, and we have a Buckner flask, which is the bottom here, and a Buckner funnel, which is here. Then I have a filter paper on top, and what students mostly get wrong when they're doing this is they pour it in too quickly and then the solids go around the edge of the paper. So what you've got to do is pour it slowly and pour it down the center. And what should happen is it will be sucked through by the vacuum, okay, and you will start to get your orange precipitate which will form on the paper. Okay, and all you have to do is once you have filtered this, you leave it to dry for a day or so, usually in the fume cupboard at your school, and then you can perform a melting point analysis to identify what the actual ketone was in the first place. We're now at the last stage where we identify our 2,4-DNPH derivative. And then we can know what the ketone or the aldehyde was at the start, because there is a database online which shows you the exact melting point of derivatives of different aldehydes and ketones with 2,4-DNPH. And we have our product here, and you can see our product of our nice orange precipitate. And that orange precipitate can be loaded into a melting point tube. So a melting point tube, bit of glass that's sealed at one end and open at another. And you take the open end and you literally just hit it into the solid, and so it goes into the tube. So you probably see that there, you can see here that is in the tube. And then all I do is take that, turn it the other way, so the sealed end is here, and then just start hitting it on the table. And I hit that very, very gently, and as I keep doing that, the solid falls down the tube and then ends up in the end of the tube. And as with a kind of Blue Peter moment, okay, you have got a pre-prepared tube here which has your solid in the bottom. All you do is then take that, put it into your melting point device, and lots of schools have devices like this, and then you set it to around about the temperature which you feel that it's going to melt. Now all we do now is look at the window, and as we look in the window we'll then see what it looks like when the 2,4-DNPH derivative melts, and we'll monitor the temperature. So now we've gone through all the stages of doing a 2,4-DNPH and using that to identify a ketone or an aldehyde. Okay, so the stages are, just to go over again, recrystallization, you then filter, and then after that you will take the melting point and compare it to a database of known melting points of 2,4-DNPH derivatives. And we're now going to go back to the studio so that we can put that in the form of an exam question. So let's now go through an exam style answer about using 2,4-DNP to identify a compound. The derivative has a specific melting point, so can be tested after purification. That purification is done by recrystallization. So we're just going to go through the recrystallization now. So the recrystallization is in 3 steps. Dissolve in a minimum amount of hot solvent, reduce the temperature by placing in an ice bath, and then filter, wash with cold solvent and dry. Okay, so you filter first, then wash with the cold solvent and then dry. Afterwards, you take that dry product and you compare it to a melting point database. If it's pure, it'll have a sharp melting point that's only a couple of degrees in its range. If it's more than that, it's impure. And if the melting point is lower than you would expect, it's bound to be impure as well. And that is how you do recrystallization.